The Marine Tech Expo is going virtual this year. Hello and welcome to day 2 of Marine Tech Expo 2021 from Plymouth in the UK. I'm Justin Lee and I'll be guiding you through the day's events and putting your questions to some of our keynote speakers. You can submit those questions in the comments section of the YouTube channel. We've lined up a wide range of world-leading experts to join us throughout the day as we focus on sustainability in the marine sector. How can we use technology to clean up and protect our oceans and to monitor our impact on marine life? How do we make the maritime industry greener? And how can we further harness offshore renewable energy? Those are some of the themes we'll be considering, and we'll look at some of the latest technology in action during a series of at-sea demonstrations. First of all, to help us officially open day 2, I'm delighted to welcome Richard Stevens, who's chair of Marine Tech Expo.
Hello, I'm Richard Stevens, and it's been my privilege to chair the Marine Tech Expo steering committee for the last number of years, and well, in fact, since its inception. So it gives me absolute great pleasure to welcome you to all to day 2 of the event. I hope that you found yesterday useful and that you've seen some of what Plymouth Marine Tech Cluster has to offer, and that we've whetted your appetite for day 2. So without further ado, I'll let you get on with the day. Thank you.
Also officially launching day 2 of the 2021 Marine Tech Expo, here's Sarah Kenny, who's Chief Executive of the BMT Group and Chair of Maritime UK, the collective voice for the UK's maritime industries.
Good morning and welcome to the Marine Tech Expo 2021. I am Sarah Kenny, the Chief Executive of BMT Group and the Chair of Maritime UK, the umbrella trade body for the UK marine and maritime sector. It is great to see that so many of you have been able to join us today. This event is truly a great example of a collective effort from representatives of industry, the public sector and research partners to deliver what promises to be a productive, thought-provoking event with a fascinating programme and some fantastic speakers. I would like to start today by wishing you and all of your families well. I am sure that, like me, you look forward to the resumption of something approaching normal for important events like this. Although that said, especially given our theme for day 2, I would prefer to see us reach into the best that technology has to offer to properly embrace and enable live virtual working, given what we all need to achieve on sustainability. Reflecting both as the Chief Executive of an international maritime science and engineering consulting firm and as the Chair of Maritime UK, I have to say that the experience of the past 12 months of how we as a collective of government, industrialists, academics, media and society have responded to the global pandemic has caused me to pause and consider the UK marine and maritime strategic agenda overall and what our approach should be from here on out with regards to skills, sustainability, technology and innovation, competitiveness, growth, policy and regulation, our brand, and the true level of collaboration that we need to succeed. The size of the prize when we get this right is significant, with the global maritime economy due to almost double in size to $3 trillion by 2030. And we start from a position of real strength as a maritime nation with a rich heritage of maritime business and trade success, and of course, innovation. Back in 2019, the UK government published Maritime 2050, which set out for the first time a truly pan-industry government strategy for the UK marine and maritime sector, covering all of the aspects that I have just mentioned. The priorities and the roadmaps contained within Maritime 2050 clearly set out a route to a transformed sector, and I reflect that much has been achieved in the past 2 years against the short-term recommendations of the plan. For example, the work on regional development and growth is exemplified here in Plymouth through the leading work on maritime autonomy here, including research into systems, data collection, analytics, and exploitation techniques, and the launch of the Smart Sound Testing and Development Range facilities, which offer a unique environment for experimentation and collaboration. Furthermore, I am delighted to see the Freeport Status Award for Plymouth. I know that the ambition and the drive here is high and that there will be much, much more to come. Beyond these superb local achievements, the UK government Build Back Better strategy, the launch of the Integrated Review, the Defence, Security and Industrial Strategy, and soon to be launched refreshed National Shipbuilding Strategy all signal a significant renaissance in demand for marine and maritime skills, services, facilities, and capabilities. And this plays directly into the UK's wealth of expertise and experience in the marine and maritime sector. And of course, I can't talk about the last year without mentioning the pandemic. The marine and maritime sector, as many others, was already facing a period of profound change prior to the COVID outbreak. We are now arguably seeing an acceleration of that change with new and rapidly changing geopolitical imperatives, nationalist and popularist political agendas, the refocusing very rapidly in some cases of investments, the impact of rapidly emerging technologies, the changing nature of trade relationships between and within nations, significant changes to established supply chains, and a clear emergence of demographic and societal change, which is driving demand for new ways of working and thinking and developing, therefore, new business models. On that technology point, I don't think anyone in this virtual room could argue that there hasn't been somewhat of a digital explosion in our business and home lives in the past 18 months. From a marine and maritime perspective, both the pandemic and Brexit have acted to accelerate digital adoption, especially on the themes of regulatory compliance, data handling and analysis, and the need to adopt rapidly to remote working, whilst also looking after the well-being of our seafarers. In the post-pandemic era, perhaps the challenge may be integrating these solutions, adopted in a rush, into routine operations before the progress we've made gets lost in the desire to return to normal. Looking ahead, it is clear that the shipping sector has ambitious plans to apply digital technology to further transform, especially in the areas of smart navigation and vessel performance. It is also clear, and you will see this for yourself at this event, that there is both high ambition and rapidly increasing technology readiness of remotely operated and autonomous marine survey, sensing and surveillance technology. The potential offered by these technologies for reach, persistence, and timely access to information and data at a distance is both considerable and exciting. Aside from the clear use of digital to achieve regulatory compliance, to drive much needed operational efficiency, and to make improvements in safety and crew experience, developments in digital and autonomy potentially offer a real leg up to our sector in the understanding of our seabed and marine environment, and in turn, therefore, offer benefits to our understanding of sustainability. The pandemic has coincided undoubtedly with a heightened awareness of environmental risk and sustainability. And this is translating into real action in a way not seen before. Regulators such as IMO had already set what looked like a progressive challenge to achieve decarbonisation by 2050. And the 2019 Clean Maritime Plan in the UK was clear on our route to net zero. However, in the past few weeks, the global narrative has shifted even further, with China and the USA making bold statements about their environmental goals. And here in the UK, our Prime Minister has just committed to including shipping emissions within the UK's net zero targets. The decarbonisation of the maritime sector through the introduction of new fuel alternatives, more efficient technologies, and green infrastructure will be critical. While shipping could be argued to be the most carbon efficient way to transport goods, that argument simply doesn't hold up as an excuse to do nothing. The sheer volume of maritime traffic means that our emissions are significant, and steps must be taken across the entire maritime ecosystem to ensure a cleaner, greener future for all of us. So digital, environment and sustainability have arrived and are here to stay, and must rightly be key tenets of our future, both operationally inside businesses and in terms of what we offer to our clients and to society overall. And on top of that, what we are also witnessing is a real change of the pace that this change is expected to be driven with. And on that note about pace, I think we have an opportunity here as the UK marine and maritime sector and the businesses within it. I believe that for all of the current effects and the inevitable ongoing impacts of the pandemic, perhaps two positive outcomes in a post-COVID maritime world are the increased societal awareness of both the role and the importance of our sector. So as a sector then, we need to innovate in the way in which we design and develop solutions, making use of emerging technologies which can aid collaboration and accelerate product development, and adopt different approaches to supply chain and product integration to accelerate exploitation of technology, driving efficiency and productivity, reducing costs, importantly, attracting and retaining a skilled workforce for our future, meeting our environmental commitments, and ensuring that safety and regulatory aspects are all addressed along the way. The level of ambition and technology-led innovation that you will see in this two-day conference tells me that as a sector, and with government and policy support, we already recognise that we cannot stand still, which is great news. But as I have highlighted, technology is only one part of this picture. And as technology-driven disruption increasingly impacts our sector in a post-COVID world, we are faced with the hard business reality of maintaining productive, continuous, safe and efficient marine and maritime operations, at the same time as needing to make these perhaps courageous moves towards a different future, along with all of the associated investment as part of a truly global industry where some others may not adopt at pace or at all, and of course, some may go faster than us. So we need to recognise that we're presented with what I am sure with hindsight will be a unique window of opportunity and time to really transform our sector. We must both face and embrace the reality that there is a huge opportunity here as part of a truly global industry. Technology is and will continue to play a pivotal role, but perhaps the real challenge and opportunity is that of collaborative and possibly courageous leadership, and perhaps that's the biggest priority for us all. In closing, I am delighted to be part of the Marine Tech Expo 2021 in Plymouth. I truly believe that this event is an opportunity to engage with some of the leading minds in the field and to facilitate the necessary conversations about the actions that are needed to ensure that we all make the most of what digital technologies can offer and achieve a greener and more sustainable future for all. Enjoy the event, ask questions and get involved. With that, I will hand back to the studio. Thank you.
Thank you to Sarah Kenny and to Richard Stevens. Now, straight on to our first guest speaker. Diane Gilpin is from the Smart Green Shipping Alliance and also advises the UK government as a member of the Clean Maritime Council. Diane is exploring the complexity of systems changes and the opportunities arising for the UK maritime sector.
My name's Diane Gilpin. I'm the Chief Executive and Founder of Smart Green Shipping. It's a pleasure to be here. Thank you so much to everybody for the invitation. I'm going to talk about wind assist today, and first of all, let me introduce myself and my company. I lead a purpose-driven systems design house, and our purpose is to reduce emissions from shipping by 0.5 gigaton a year, in line with the Paris Agreement. And as we all know, every journey, and I'm not sure that it's appropriate, but every journey starts with a single step. And so our first key objective is to fit primary renewable energy, by which I mean wind, onto an existing commercial ship. And I'm going to talk you through that journey and take you on it with us. So the first thing I'm going to do is to introduce the idea around in the context of global shipping. Now, everybody knows that 90% of everything that we consume is moved by sea, and we know that it's a significant contribution to global greenhouse gas emissions, and that whilst 2 or 3% of the total doesn't sound like a great deal, it's about 4 or 5 times more than the UK, and we know how hard we're all working in this country to decarbonise. The IMO, the International Maritime Organization, has committed to decarbonisation by 50% by 2050 and is currently working on making those regulations and policies more stringent. Therefore, we believe that wind assist has a very significant opportunity to penetrate the global fleet, and we think that we are extremely well placed in the UK and particularly in the southwest to address this challenge through 21st century wind technology. I just wanted to touch on the current discourse around shipping. Most of the narrative is around looking at alternative fuels like hydrogen or ammonia or methanol, and there is absolutely a place for those fuels. But what we need to understand is that discourse is led by the big blue chip shipping brands, most of whom are container vessels and most of whom can only really look at alternative fuels. But there is a significant amount of the global fleet that is ideal for retrofitting with wind assist, but they have limited access to research and development and capital. We know that we're living in a climate emergency. We know what an emergency response looks like from our response to the pandemic, and that's the level of commitment and ambition we need to be seeing in global shipping. I think the most important thing to think about is, whilst this is a climate emergency response, it is also a commercial response. There are 60,000 ships in the global fleet, and that fleet is growing at a significant rate year on year. And the Department for Transport Clean Maritime Plan, which I was a contributor to, suggested through research that up to 40,000 ships in the global fleet were suitable for wind assist, either as retrofit or as new build. What's significant and important about this, apart from the market size, which is estimated to be worth £2 billion a year, is that we start to reduce emissions in the very short term by retrofitting wind, and that's really important. The short-term emissions reduction is critical in the climate emergency. And fitting wind also allows us to mitigate the alternative fuel risks presented by methanol or hydrogen, which is less fuel dense, more expensive, and it changes the entire proposition of the shipping industry. So Fitting wind allows us to use these more expensive and less dense fuels and get back to some sort of economic parity that we're used to in the industry. Just very, very briefly to touch on this as a commercial opportunity, even with only 26 installations in the next 6 years, 5 years actually, I've missed a year because of COVID, we expect to see significant exit valuations for our investors, and we're having very promising talks with investors at the moment. However, there are huge obstacles to the uptake of wind assist, and I think it's not just us that are saying so. Academic research conducted for the European Union and by the University College London both point to lack of trusted performance data and lack of access for funding for full-scale demonstrators as a problem. Some Innovate UK funded research we did in 2018 and 19, which was collaborative working with the shipping industry, also identified the fear that ship owners have of being first movers, and the fact that because of the complex nature of the makeup of the commercial makeup of the shipping industry, there is a lack of available capital to do that. So that's what's stopping us, and that's what we're currently talking to investors and government about to overcome these obstacles. Now, we've seen competition in the wind assist area, and that's coming from companies and countries that are based overseas. And the competition is being supported by government, and they have been able to overcome this innovation hurdle and are by using government support, and are now rolling out commercially. And those technologies, Flettner rotors, have been validated as saving fuel by the same team at the University of Southampton as have validated the fast rig fuel saving. And we are at least twice as efficient as a Flettner rotor. So the case that I'm making here is that the UK supports technology developed in the UK by the UK and creates socio-economic benefits for Britain as a result. So fast rigs, what are they? This is a visual that we created from our collaborative Innovate UK study. We worked with Drax, we looked at a specific ship on a specific route, and we modelled the use of fast rigs in that real world situation in a virtual computational fluid dynamics suite, and showed significant savings. But before, I'll talk a little bit more about that in a minute. Before I do, I want to underline that, you know, people think that wind is unpredictable. I would argue that using big data analysis, which we've done by developing a prototype with support from the European Space Agency, we can predict wind better than we can predict the fuel price of alternative fuels on a commodity fuel market in an energy constrained future. So I think by fitting wind now, what we're doing is fitting certainty. And you know, there's a lot of uncertainty as we go into the future, and certainty is going to be a key commodity. So we know how to use big data analysis to predict the value of the wind. So the fast rigs are automated, they're retractable, they're robust, they're made of steel and lightweight extruded aluminium segments. That makes them affordable, and it makes them recyclable, which is particularly important as we think about the use of resources in a global climate and nature emergency. And we've validated this performance on this ship running from the US to the UK as saving at least 20% fuel and greenhouse gas emissions. So what we're about is harnessing that abundant energy that sits in the ocean. We're about looking at the whole system, not just the technology. Our short-term action is key to the climate, and our plan to go forward is shovel ready. We are bringing together the vision of delivering that technology as the first step in the journey to achieving our purpose of 0.5 gigaton fuel saving per annum, and that we will be proposing to use zero emission solutions and smart energy adaptation for across the whole fleet. I'm really looking forward to any questions you have about this. It's been a bit of a high level skim across the top, so I'm sure there'll be more, and I'm looking forward to talking about it shortly. Meanwhile, many thanks for your attention, and look forward to talking more.
Our thanks to Diane Gilpin. This is Marine Tech Expo 2021 from Plymouth, and we continue with our theme of sustainability. Here in the southwest of England, we're surrounded by the sea and we often witness its awesome power. But how can we do more to harness that energy? Our next speaker is Simon Cheeseman from Offshore Renewable Energy Catapult Limited and is responsible for their marine renewable strategy.
Hi everyone, I'm Simon Cheeseman from the Offshore Renewable Energy Catapult. I'm here to give you a 10-minute brief just on the wave and tidal industry, just a bit of background for the Offshore Renewable Energy Catapult. So we're a not-for-profit SME innovation organisation. We're UK-wide. We've got research and test facilities up and down the UK, as you can see from the map on the right-hand side of your screen. And importantly for Marine Expo, we work with all manner of organisations. We work with small, medium-sized enterprises, original equipment manufacturers, as well as academia. And our role is actually to help organisations be innovative and get technology to market so that that collectively sort of drives down the cost of renewable energy. And we cover offshore wind, wave and tidal energy. This really talks about the science behind wave and tidal energy. What's it all about? So waves are produced by wind energy moving across the surface of the ocean, and tides are caused by the rise and fall of the ocean caused by the gravitational pull of the moon and the sun on the earth. So in the two diagrams on this slide, you can see that in the UK, we've got roughly around 23 gigawatts of wave energy, and that's being caused by temperature changes out in the Atlantic that then form winds, that then form waves, and they come through in the North Atlantic onto the coast of the Hebrides and Scotland, and down in the southwest through the Celtic Sea onto the coast of sort of Cornwall and Wales. So that's where our best wave energy is. And it's a similar position for tides. Tides, as I say, are caused by the rise and fall of the moon, the ocean caused by the gravitational pull of the moon and the sun. And around the UK, we get very strong tidal forces as that North Atlantic flows in towards Scotland and channels around all the islands around Scotland, and a similar position as it flows in through the southern approaches onto Land's End and forces its way up the sort of Bristol Channel and through the English Channel. So we've got very good wave and tidal resources within the UK. And as a maritime nation, you think, yeah, we ought to make use of that in some shape or form. So let's have a look at the technology. You can see here where I've got two shots of the different types of technology. So a sort of around the world view of wave energy and the types of wave energy systems that are out there. And you can see that all these systems are actually quite significantly different. And that's because of the physics of wave energy, and that developers tend to focus on one part of the wave to draw energy from. And that may be the leading part of the wave, it may be the sort of moving part of the wave, or it may be the sort of tail end of the wave, or even some developers work in what we call the littoral zone, which is where the wave is almost crashing onto the shore. And then other developers are perhaps subsea, where the wave extends down to almost the seabed and can develop devices there. So you can see that the sort of types of devices, that they all tend to be fairly large steel devices, but they're all completely different in the way they operate. They fall into sort of 6 different sort of categories, but the challenges that they face are very much that translation of wave energy through motion or pressure into electrical energy, and making sure there aren't too many losses in the wave. But we know we can connect, we know we can manufacture wave energy devices and connect them to the electricity grid. The question is all about sort of reducing costs and how we do that. The position for tidal is slightly different. Tidal is considered slightly more mature. We've seen some consolidations in the design. I took a different angle of approach on the presentation for tidal here, and just showed you the sort of activity that's happening more closer to home for the Marine Expo along the Channel region in one of the projects that the Catapult's running. And again, you'll see generally we talk about tidal as being, there's been a level of design consolidation around three-bladed horizontal axis turbines. But in effect, we've also got vertical axis turbines developed over in France, and outlier systems like Minesto's flying kite system. So again, still room for consolidation, more standardization and cost reduction across the wave and tidal energy sector through the technology. And that's the key point for the Marine Expo, I think, is trying to encourage not only wave and tidal developers to get involved, but more enabling supply chain activity to get involved in some of the innovation requirements that we've got. And I'll come on to those on my final slide. But you may ask, why wave and tidal energy? Why is that important then? Well, we're all focused on climate change and recognize the necessity driven by climate change for net zero targets in 2050. And so that's driving the need for strong renewables base. But that renewables base isn't just about wind power and solar. As I've pointed out already, we've got a great wave and tidal resource around the UK. We've got superb academic institutions like University of Exeter, University of Plymouth, who are involved and at the forefront of wave and tidal technology research and innovation. And we back that up with world-class test facilities as well. So we've got the Coast Test Tank at University of Plymouth, and even the Offshore Renewable Energy Catapult provides drivetrain test facilities for sort of cable testing, and anything that needs to go offshore, it can be tested onshore at ORE Catapult. And then importantly, when you make that transition to real seas testing, then again, the UK's got some great test facilities, such as the Falmouth Bay test site and the European Marine Energy Centre in Orkney. And the backdrop to that is an existing strong supply chain that's already working offshore, already works closely with offshore wind. And so those skills and that technology are equally applicable to wave and tidal. And it's resulted in a fairly healthy job creation at the moment, with estimations of greater economic benefit in the future heading out to 2040. And certainly, a lot of investment generated in sort of coastal regions. What's happening out there? What is happening in wave and tidal world? So we've got a healthy number of wave and tidal developers already operating in the UK, with a healthy amount of investment behind them. But what these wave and tidal developers need to prove is that they don't get an automatic seat at the table with the renewables. They've got to prove that they can be cost effective. We're very conscious about not having or not wanting to put costs on consumer bills, and people will only pay a certain premium for renewable energy. So we're working with wave and tidal developers to drive down costs, and we do that through a number of specific ways. Learning by doing, which is actually just getting out there and deploying systems and learning almost by mistakes, but learning how to do things much better. Importantly from Marine Tech Expo, through innovation. And the innovation we need is around sort of different materials, around different control systems, around different energy transition systems, around dynamic cables, around moorings, around offshore vessels. And so a myriad of different things where we need innovation and support from the supply chain. And all those things together then enable us to create economies of scale and thereby create greater market confidence. And this features very strongly in sort of today's political agenda about building back better, and the whole ethos about innovation. And coming out of the G7 summit that was held in Cornwall last month, this pulls together nicely the fact that wave and tidal can be an indigenous industry for the UK. We've got very strong focus of that down in the southwest and in the rest of the UK, and it's really important that people who are attending the Marine Expo conference actually are able to get involved in supporting these challenges and help us drive forward this sector into the future, because it's got a superb opportunity. So I'll stop there, and I'll come back for any questions. And my final slide is just contact information to get in touch with me at ORE Catapult.
Some thought-provoking stuff from Di and Simon, and a chance for you to put your questions to them now. Don't forget you can put your questions in the comments section of the YouTube channel. And Di and Simon are with us now. Welcome to Marine Tech Expo 2021. Good to see you both. Di, first of all, let me come to you. Some fascinating stuff that you were showing us there. And first of all, just take us through the key technical challenges. You talked about the sort of retrofit of wind energy on existing ships, but what are the key technical challenges for that?
So, hello, thank you very much for inviting me. It's been a real pleasure to join. Very sad not to be there in person, actually, as a Devonian. But the technical challenges have been surprisingly demanding. What we started out doing was a new build design back in 2010-11, and that is sometimes easier than it is to retrofit. So what we're looking at is how do we take our technology and install that on a ship that is not necessarily optimized in terms of the hydrodynamics. So the ships are optimized for cargo carrying, and there's immense logic in that. But if we're trying to fit our fast rigs to effectively a brick, we're going to have to work much harder moving that hull through the water than we would if we had it more designed to be hydrodynamic. So that was one element. The other elements have been around the operational implementation. So we spent a lot of time working with ship owners, working with ports, working with the crew to understand how this technology could work in the real world. I mean, it's relatively easy to put wind on a ship and sail it around if you don't have to come into port and load and discharge cargo, but that kind of negates the point of the whole thing. So we spent a lot of time in Liverpool with the ship owners, Ultrabulk that we've worked with. We spent a lot of time in Hull with Drax, with their port facilities, understanding how the loading and discharge worked. And we spent a lot of time working with the Space Agency, European Space Agency, understanding the route. So the rigs retract so that they can get under bridges, so that they can get under the, so they can get in and out of port easily enough, and so that they don't create a visual intrusion for the crew. Now, all of that was technically quite challenging. So it looks really straightforward, but the challenge is interfacing with the land side and the ship operators to make sure it works in the 21st century logistics system.
And of course, moving cargo is all about maximising your space. How much of a challenge is that in terms of the deck space that you would be taking up with wind assist energy compared to how much deck space operators want for moving the cargo?
Well, excuse me, the deck space issue is interesting because we've got the hatches. We spent a lot of time understanding the different dynamics of different ways of opening hatches, which I won't go into right now, but there's a lot. It's a lot more complicated than one might think. What we have been able to do is figure out a way of installing a steel foot, which is very much like a crane that you would see on a small geared bulker. So it's not taking up a huge amount of deck space, but we do need to find room to lay the rigs down on the deck. So, and we need to keep sufficient space between the safety barriers and the access to the deck. So that's why the rigs fold in and fold down. But it's not taking up a huge amount of payload space. And when it works with the alternative fuels that are coming into the market, like ammonia or hydrogen, which are much less energy dense and require bigger tanks than fossil fuels, we are able to offer the wind as a balancer, if you like. We can provide a 20% of the power requirement from direct thrust, which means that you need to use less of this less energy dense fuel. So as we go into the future, we're hoping those two things will balance themselves in a way that makes the proposition for shipping to move cargo as cheaply as possible, as acceptable as possible. I don't think any of us imagine that the future is going to cost the same as it does with fossil fuels, but I think what we're trying to do is to balance out requirement of energy to move things as cheaply as possible.
And it's interesting hearing you saying that you'd been to ports to see about port operations. What about the response from the ports? How feasible do they think this is in terms of for instance, loading and unloading? We see port operations with lots of crane activity. So retracting the devices allows unimpeded access to the deck for loading and unloading.
Absolutely. I mean, and I have to say the ports have all been very, very welcoming and warm and hugely creative, as indeed have all of the participants in our collaborative study. It's been a real joy to work with those creative minds in their own specialisms. But our intention is that the ship arrives in port with the rigs on deck, and it is not materially different from a ship without fast rigs fitted to it. So the port operations can get on with their job as if it was any normal ship.
Lots more questions for you, Di, on the technology, and hopefully more questions coming in. If anyone wants to comment, those questions can be posted on the YouTube channel. I just want to bring Simon in at this point because we know in the southwest of England the power of the sea. It's now the question of harnessing it, and a lot of work has been going on in places like Cornwall over the years to harness the power of the sea. How can people, though, get more involved with wind and tidal energy, companies and individuals?
Yeah, good question, Justin. There's excellent opportunities for people to get involved in wave and tidal energy. We've known for a long time that we can harness the power of waves and we can harness tides to produce energy, and we know we can connect that up to the grid. And we've been doing that for a long time, but it's all about cost reduction. We've got to make these systems a lot cheaper to operate, because whilst people will embrace renewable energy, they won't be prepared to pay too much for premium for that electricity. So what we need is innovation, disruptive innovation to support cost reduction. So different types of materials for devices, different types of install devices, more reliability in the technology, and also really a greater degree of automation, because working offshore is very dangerous. We don't want to take people offshore. We want to do as much pre-commissioning work onshore, and so we're increasingly relying on sort of autonomous systems to support offshore operations. So from any sector, you can have different types of materials from the automotive industry, materials from the aerospace industry, advanced sort of software, advanced sort of control and maintenance systems from other sectors. We've even had involvement from people who are involved in the America's Cup racing and developing different types of sails. And those sort of materials can be used for wave device development and sort of tidal technology as well. So the catapult works with both academia and industry, and whether that's small, medium-sized enterprises or original equipment manufacturers, to help develop and help companies be innovative to support the cost reduction for wave and tidal. So if companies are interested, they can get in contact with me, and we'll signpost them and work with them to get them involved.
I'd be keen to expand on the autonomy side of things, because anyone who was watching Marine Tech Expo yesterday will know we focused heavily on some amazing autonomous technology being developed in Plymouth and the wider southwest. Expand on that for us. How much of a difference, how much of a game changer could it be for wave and tidal power in terms of bringing costs down?
It'll be massive. It'll be absolutely massive, because you can use, even today, you can use autonomous systems to inspect assets that are underwater. It's no different from sort of oil and gas technology in that sense. And even if you look at coming in from other sectors, we've got technology now that can pick fruit, so pick tomatoes and things like that. And if you apply that sort of technology and marinize it, put it underwater, so that we can actually look at the underwater environment and assess what's happening to the ecology under the water at the same time. So autonomous systems can do lots of things like that. They provide your eyes and ears underwater to enable you to do things. So wet robots are very much part of the future for offshore renewable energy.
In Di's presentation, she was giving us the overview of wind energy, that endless supply of wind energy. With bountiful supplies of wind, why do we need wave and tidal energy?
Yeah, good question. So the wind doesn't blow all the time, unfortunately. And if we think about solar power, the sun doesn't shine all the time. So times, during the winter when you can have some calm days and there isn't a great deal of renewable. The key thing about tidal is it's predictable. You can pick up your tide timetable and you'll know exactly when the tide is coming in, when it's going out. If you've then got a generator that you can put underwater, you know exactly how much energy you're going to get out. And that's really important. And that's really important as part of balancing the grid. So the grid knows how much energy is coming onto the grid, so it can match it with demand. And also wave and tidal energy. If you think about our current levelling up agenda and trying to invest in local communities, particularly coastal communities, a lot of activity for wave and tidal is carried out in these coastal communities. We've got the ability in the UK to actually build these devices and operate them. So it's a really strong indigenous capability that we've got in the UK, and we're a maritime nation. We've been operating offshore for a long, long time, and we're operating all over the world. You see the fabulous resource that we've got around the UK, especially around Devon and Cornwall. Let's use that, and let's get our young engineers to apply themselves to support the wave and tidal offshore renewable energy.
Tell us a bit more about their vulnerability, though. We've seen over the last few years more extremes of weather, sea conditions becoming rougher, more violent. How vulnerable are these systems at sea?
Yeah, so survivability is paramount, and that makes the systems quite big, quite chunky. And then there's always that compromise between making sure you get the engineering right and that you don't over-engineer these systems. But traditionally we've been building systems to cope with the 100-year storm, and then suddenly it was the 50-year storm, and then suddenly we're sort of seeing those storms a lot more frequently. So our engineering is making sure we stay within the right parameters, but at the same time recognizing the sort of cost issues, and that's why it's really important that we sort of learn from other sectors. I mean, oil and gas, they've been working out in these far offshore, very deep oceans for a long, long time, and a lot of tidal and wave devices will sit comfortably, below the water level on the seabed. And so, although they still feel some wave impact, it's not as dramatic as those systems that sit on the surface of the waves. And then, those same storm conditions mean that these systems are difficult to maintain, which is why they need to be reliable. You can't always go out at the drop of a hat to go and recover a system if it needs to be maintained. So we have to look very closely at that balance of sort of wind and wave conditions and weather conditions as well to maintain these systems.
Di, let's bring you back in, because it was interesting hearing you talk about the response from ports that you've worked with. But what about the shipping industry more widely, ship operators? How much of a buy-in are you getting from them to the idea of wind assist?
Huge. The challenge is that nobody wants to be the first mover. And I think it points to Simon's conversation there, which is, this is early stage technology. We need to commercialize it. We need to scale it so that we can start to bring the manufacturing costs down and make that acceptable to the market. And I think it's entirely rational that the shipping industry should think like this. I mean, I don't know anyone who would want to have been the first person to put a solar panel on their roof. Might have been too heavy, the whole building might have collapsed, and you might have not got any energy from it. There needs to be an innovation process, and I think that's what the Catapult does so brilliantly. And we work in a very similar way. We're looking at working with America's Cup teams, we work with materials, different materials, we're looking at recyclability. So what we've been doing in working directly with the shipping industry is understanding what they need. And so they are concerned about being first mover, and they're concerned about the additional capital cost. So we have developed a customer proposition where we will lease the equipment to them, and then at the end and during the course of the process of leasing it, we will provide operation and maintenance. And if there is a significant technology upgrade, we would commit to upgrade that. Our wings are made out of aluminium and so are 100% recyclable, at the end of their life, we would take them back into our ownership and then release the value from that. So it starts to create a different commercial proposition. The ship owners don't have to own the capital equipment. We can lease it out of the fuel savings that we can predict, and we can do that using historical data. And I take Simon's point absolutely, that the storm that was once a decade, once a century, is now much more frequent. But there is still a high degree of consistency on how predictable wind is, and we are able to insure against the wind not blowing for our customers. So that's a really interesting approach for the market, but they want to see the technology developed. That's the truth of it. And I think that's what we're doing now, is going through the innovation process. But I think the key point about wave and tidal and wind for ships, and it's allegedly unpredictability. I think we need to think about what the alternative is, which is fossil fuels. That those fuels, and indeed alternative fuels, will always be connected to a commodity trading market, and that's volatile. We have no idea what the human behaviours are around trading on commodity markets. We know that the wind, the waves, the tide is entirely predictable. We know there's a capital cost for harnessing that energy, but we can start to play with different financing models to make that accessible to the market. So it's about the technology, it's about the technical, the digital and the commercial elements all being intertwined at the same time.
And what role does legislation play in all of this? Because we know there are strict measures being set down for decarbonisation of the shipping industry over the next decade or so, next few years. But what more needs to happen in legislative terms to enable more motivation for this type of wind assist energy?
We need to have much clearer, much more stringent. I mean, if we're thinking of it in the terms of the climate crisis, then the legislation needs to be much more stringent and much closer. At the moment, we've got a 50% by 2050 goal, and what that means is, we're human. We won't do it. It's like doing your homework. You're not going to do it well in advance. You'll do it the night before you've got to hand it in, and that's the fear, that we're not going to be responding to the need for short-term emissions reductions with the kind of legislation that we have at the moment. But the IMO is really complicated, and I get that. So we need to expect, hope that the politicians and the diplomats will continue to drive that process. And meanwhile, we have to get on with what we can do, which is develop market systems that are irresistible to the market in the current legislation. And I think that the tightening up of various regulations like the EEXI and the CII, they're having an impact. The shipping industry does want to do something. I haven't met anybody who doesn't believe that climate change is real, doesn't want to do anything. It's just at the moment, the policy is not quite robust enough to stimulate action. And one final point is there's not really a very clear research and development facility for anything. So the UK government has put a little bit of money in. There's not very much international R&D funding, and most of the shipping industry comprises small, medium enterprises getting on with a job, moving cargo as quickly, as cheaply as possible, and they're not really set up to do R&D. So that's a big gap that we could use, we could fill and make a huge amount of progress in this country if we did so.
And that seems key to moving this whole thing forward. You talked in your presentation about people being reluctant because of a lack of trusted data. Until there are proven tests going on, that tangible information that people can base a decision on, it's going to be difficult to move things forward. How do you stimulate that sort of test and development sector?
Slowly. Is the short answer, but it's about collaboration. As I said, everybody wants to do something. How do they do it? We ask all of the people. So we work with ship owners, we work with cargo owners, we work with naval architects, and we ask everybody to take a step in to move towards the goal. And that collaborative effort, the coalition of the willing, is enabling us to put a test rig onto a ship in the next few months that will enable the industry to kick the tires and give us the data that we need to be able to give the financial market, the insurance market, confidence to invest funding in the first of kind.
Oh, so there is a test rig about to start providing data by the end of this year.
With luck and a following wind, we're still doing the dots and I's and T's and all the rest of it, but that's where we're heading. And we've been badly disrupted by COVID because it's been, like everybody else. We did the Innovate UK study in 2019. The results were really promising, but we have been unable to go to a full-scale test until we've got through the COVID crisis. So we're closing in now on the funding to put a full-scale test onto a ship, and I'm hoping to do some announcements soon.
Okay, we'll look out for those. Simon, I wanted to bring you back in on the issue of legislation, because talking to Di there's this carrot and stick approach. The carrot is hopefully lower costs for everyone ultimately, and the same with tidal and wave energy, but you've already outlined the considerable costs involved in getting the infrastructure in place. What role can legislation play in helping that? There are clear legislative plans in terms of decarbonisation, but is that enough? What more needs to happen?
Well, I think the conditions are absolutely perfect now. Everyone acknowledges sort of climate change. Everyone is recognising our sort of 2050 net zero targets, and so we need to do as much as we can to be able to achieve those. I recognise what Di says about leaving your homework to the last minute. I always did my homework in advance, actually. So, this is what tidal energy and wave energy are trying to do. We're trying to, make sure we've got some insurance policies for the future, so that we can provide an energy system that's got various parts to it that meets the requirements of future increase in demand. And actually, legislation is actually helping us quite a bit. I mean, looking at the environment, first of all, before we deploy anything, we have to do a 3-year environmental impact assessment, and we're collecting data about the sort of the ecology, around the seabed. And it's surprising how little we know about the sea and the sea around us. It's that last great place to be explored. And so the data that we collect and we eventually put out in the public domain is incredibly useful. For regulators, for people studying the seas. And a lot of the time when we're putting things in the water, we're actually creating a new ecosystem, perhaps where there wasn't one before. So we're creating sort of fish stocks and things like that. So a lot of positives for renewable energy. But we work very closely with legislators and regulators to make sure that we work in harmony. We recognise, there are other sea users out there, both commercial and leisure users. And so, we need to work together to make sure that what we do is safe, it's not intrusive, and actually we can look at the benefits that we can bring to that ecosystem. Probably what we really need, though, is, it's always more support from the government. So with any new technology, someone needs to take the risk in terms of introducing that technology and sort of prop it up for a while until it gets established and the market gets established. So, we're working with the government to understand what that, regulatory need would be. We think we've got that established, but of course, we're at the Treasury door knocking for a pot of gold, and everyone wants their sort of share of it. So it's an ongoing discussion with government about that. But what we're seeing around the world is that majority of governments now are switching their attention to renewable energy. And we're sort of facing the same sort of generic issues about trying to get that established. So the UK is very much at the forefront at the moment of establishing offshore renewables. And we don't want to throw that opportunity away. That's a great export story for us. And, in the same vein, the Catapult is working with shipper operators for sort of installation vessels, for crew transfer vessels. We're looking at different types of fuels. We're looking at different types of hull shape and things like that. So very much sort of focused on that sort of what we call green ports sort of initiative to try and reduce the amount of fossil fuels that are needed for our day-to-day operations.
I wanted to explore the potential for wind and tidal in terms of how much of the nation's power it could provide, because that's key to a lot of this as well. We've seen how expensive and how long it can take to build a new nuclear power station in Somerset. Hinkley Point C is under construction, but massively expensive, a long build process. What about the potential for wave and tidal power in terms of how much it could contribute, particularly as an island nation, a more sort of desire to be self-sufficient in terms of energy generation in the future? So what proportion of the nation's energy could come from wave and tidal?
Yeah, absolutely. So I think our sort of 2050 energy targets have been going up. We're now at sort of 75 gigawatts by 2050. I think our demand at the moment is around sort of 30 gigawatts. We've certainly got sort of the potential for sort of 20 gigawatts of wave, 20 gigawatts of tidal around the UK. But we sort of use the term sort of economically viable. Is it economically viable to extract that, and where can you do that? But all the time the technology is advancing. We're looking at sites now that we perhaps wouldn't have looked at 5 years ago, where we can now extract energy. Turbine speeds have got much lower kick-in speeds now. It can work in much lower tidal flows, so they're more suitable for sort of estuary schemes and run-of-river schemes. And so that's attractive to sort of community energy. So the opportunities are increasing quite dramatically, actually. So wave and tidal in the longer term, and we're sort of thinking about sort of large deployments from around sort of 2030. Could really plug the gap and certainly support a lot of community energy schemes, because you remember that particularly tidal, these are relatively small, certainly smaller in comparison to say offshore wind, and entirely different to nuclear. These systems are relatively portable. We've got a project up in the Shetlands where we're taking tidal turbines and we keep moving them to look at the optimum sort of array and comparing that with our model to verify our model. So, these are relatively inexpensive systems that are mobile and can be moved around to suit. So, that's another distinct advantage for offshore renewables.
On the face of it, you and Di are talking about two different sets of technology, but I wonder how much opportunity there is for cross-sector transfer of knowledge and information. Simon, what sort of potential do you think there is?
I think we're very much joined at the hip. Offshore renewables can't operate without shipping. We both need to make sure that our futures are decarbonised. We've got to work together to make this happen. And whether we're working on crew transfer vessels or larger cargo vessels, a lot of the technologies, a lot of the challenges are exactly the same. So I think the catapult's already involved in looking at sort of vessel design, looking at the way that deck equipment is positioned and designed so that it's quick to get things in and out of the water. We're interested in the cost of fuel, because most of the costs for offshore renewables comes in that sort of operations and maintenance phase over the 25-year life of the project. So that's where the most cost is. If you're spending a lot of time, getting boats to and from those sites and spending a lot of money on fuel, that's bad. So Diane's sort of technology is absolutely the thing that we need in the future, is trying to reduce those costs and make our shipping more green.
And Di, presumably you agree that there is potential for cross-sector transfer of knowledge and information?
Oh, completely, absolutely. Effectively, Simon and I are working in the same sort of space, which is energy and innovation. How do we manage to, so we're looking at materials, we're looking at processes, we're looking at cost reduction, we're looking at manufacturing. All of those things are very similar. And I think that it's about thinking about what's the energy that we need to power the future, and it's balancing that requirement so that we can all turn the kettle on when we need a cup of tea. We can't depend on the wind on a ship to provide all of the power. So we balance the ship's fuel requirement, power requirement, wind plus an alternative fuel. We don't know which particular one will be the favourite yet. We involve autonomy as much as we can so that the crew doesn't have to retrain, and there aren't additional costs for ship owners. So yes, a lot of crossover, and I agree completely with Simon that the UK has huge potential as a maritime nation in this space, and we could lead the world in energy as we did, at the start of the Industrial Revolution. So I think this is a great opportunity to be exploiting right now.
A question's come in for you, Di, which is regarding the sort of things that small to medium-sized businesses need to do to get involved. The question is, what advice would you give to a startup seeking to launch a small coastal sail cargo operation at around 500 GRT?
You've got to find the cargo. You've got to have the demand pull in order to do that. That's the biggest lesson that I've been working in this space in 21st century shipping, wind for shipping since 2009. But prior to that, in the 80s, I was involved in a ship that ran from Plymouth to the Caribbean, actually called the Atlantic Clipper. And that business successful technically, but didn't have a reliable cargo trade. So small ships really need to have good cargo. And I think, I do spend a bit of my money at Chocolada, who import chocolate on a sailing ship. So yeah, cargo, but it's got to be quite niche at market, I would think, cargo.
Okay, Simon, a question for you, and you touched upon this earlier on, but perhaps you could expand on it for us. That the comment that's come in is that the waters around the UK are some of the most complex in Europe. So what efforts are being made to accommodate shipping, wind farms, pipelines, cables, MPAs, ports, etc.? There's so much going on in the waters around the UK. How do you fit in with Wave and Tidal around all those other activities?
Yeah, so what we do is we do a lot of what we call constraint mapping. We look at the existing constraints that are out there, whether it's subsea pipelines, cables, as your question alluded to, shipping routes, fishing areas, maybe Ministry of Defence exercise areas, that sort of thing. And then we sort of identify areas that may be suitable for us, where we think we can work around some of that other activity. But it's very important for us to, as we're going to mention before, the environmental impact assessment. Part of that process is also talking to other organisations and saying, look, this is what we're planning to do. How does that fit in with what you're doing at the moment? And obviously, there's a case of whoever's there first. And if we're coming along second, then we have to sort of move and fit in with what's already there. So we're quite used to sort of changing our sort of planned cable routes, maybe changing, the sort of the precise location of some of these devices. But it's very much about working in harmony with people. And as I said before, quite often the data that we collect is very useful for other organisations, particularly the sort of fishing organisations and things like that, and other sea users. And the sort of vessels then that we're using to deploy from a coastal port actually then bring in further investment for that port, because we're bringing in crews that need accommodation, crews that need to be fed. And so, there's a big knock-on in terms of that investment for other users.
Let's explore the environmental impact a little bit more, because there is often a great deal of concern about something being put in the sea. You've got the cables will still have to come ashore somewhere, that there's infrastructure in place. On the one hand, you're doing something to try to help protect the environment in terms of generating power in a more sustainable way. But there is always going to be an environmental impact of some kind from this technology. How do you convince those who are deeply concerned about not just tidal and wave, but offshore wind as well, the visual impact and the environmental impact?
Yeah, well, I suppose, wave and tidal tend to be under the water, so out of sight. Bringing cables ashore, we use sort of underground horizontal drilling techniques to get the cables under the beach and out into the water. But again, it's through consultation that we work with groups, and we recognise that people, want to maintain the view they have across the horizon. So we tend to push systems further offshore. So, you know, that in the end, they, you know, even on a clear day, they're probably a dot on the horizon at best. But it's all about, you know, working with people. We can't sort of turn up and just deploy stuff and expect, you know, to sort of get away with it. We've got to work in consultation. And that benefits us as well. You know, there's sort of new technology that's coming along that makes it easier for us to deploy further offshore, new techniques to improve sort of cable runs and things like that. And even, I mean, for Tidal, when we're deploying cables far offshore, because of the tidal flows, sometimes those cables would have a tendency to wander if they're not either buried or have some sort of rock mat over them. And you know, we're working with the environmentalists, and there's a company now based in Devon who make a sort of an artificial reef type matting that you can put over cables or around structures to stop scour, which actually encourages you know, sort of crustaceans and sea life to form around it. So, you know, we're creating artificial reefs and improving the ecology subsea.
We know how delicate the ecosystem is under the water, though. So how do you tread carefully? How do you tread lightly? I mean, you're putting enormous objects under the sea, using the seabed in that area. And I take on board what you said there about crustacean and others growing again on some of the infrastructure. But in terms of the initial impact, how do you minimise any consequences on that delicate ecosystem?
That's through research, and the research that we carry out with universities like University of Plymouth, University of Exeter, Plymouth Marine Laboratories, where we go out and make sure that we first of all understand the environment that we're planning to deploy in. And then probably in the research lab, we look at different types of materials and how they may impact the environment. And then we start to scale up that sort of technology, first of all within the laboratory, then maybe within test tanks. And then we've got specific sites that enable us to carry out that sort of research, so we can take a longer term view to see how these materials work within the environment over a number of years. So we're very, very careful before we deploy anything of any sort of intensity. And there's a lot of research that sits behind that, most of which is sort of publicly available.
Di, a question has come in for you about the maintenance of wind tech energy on board, wind assist energy on board ships, the extra complexities that come with that. I note you said earlier on that you would be taking on some of the ongoing maintenance, but in terms of on board, what more will crews need to be aware of in terms of maintenance of wind assist technology?
The technology is designed to be as straightforward as possible. The mantra that we adopted when working with the ship owners and the crews was, you've got to be able to fix it with a hammer. And so what we've been looking at is modular, extruded aluminium modular sections that could effectively, they're about 10 meters high, they could effectively slot in and slot out. So if one gets damaged, we could do it in port. I mean, I think the point is that the ships will be coming into port, and we're designing them to be fixed in port and not really to be managed on a day-to-day basis by the crew. And they're not there to be complex devices. If they don't work, they just get out of the way. They're intelligent. They know that they're not working. They take a break. They lie down. We're not expecting, and it's very much feedback from the industry that says we haven't got the capacity to keep fiddling about with these things on deck. And we absolutely embrace that. And you'd have to sail for a couple of voyages perhaps without the full use of all of the system. But they're designed to be really simple so that they wouldn't, I mean, like everything is, but you know, that they would be very robust. Their design is designed to be very robust. So I think that that's important. But I think that, you know, picking up on Simon's point as well, you know, we are subject to something of a false equivalent. You know, there's a lot of complex systems on ships at the moment, which people go about dealing with every single day of the week. You know, there's a lot of complexity in the fossil fuel industry that we don't bat an eyelid to. So I work with Drax very closely as our demand off-taker, if you like. They want to charter ships using our technology. And so we visit them quite often. And that part of the world, it has, it's just full of old coal power stations, but most of us don't see them. And so we don't kind of go, well, how much energy is embedded in that coal power station, and what's the energy looking like, and what's the environmental, that's a given, it's already happened. So yes, we don't want to go with the same sort of lack of understanding into the future, but we as a society need to make a decision. Do we want to continue consuming energy in the way that we do? And if the answer is yes, we have to get really creative about how we do it. And I do get a little bit frustrated by people saying, oh well, you can't put a rig on a deck, when there are hundreds of ships sailing around with cranes on them that nobody talks about. So yes, we will solve problems, but we're not going to do it with just being picked on, as it were, to be extra specially vigilant. We are extra specially vigilant because that's what we're motivated, we're mission driven. So we're not going to trash the environment, but we are trying to find solutions. A
final quick point from you, Di, is where does the UK fit in globally in terms of this technology, and what is the potential for the UK economy and jobs from this?
So my cat's just come to join us, I'm sorry to say, yes. So that's why I'm pointing at her, so do not join this call. We have calculated that in the first 10 years of our development, we could sell nearly 300 units, and that's with the cost coming down, and that could create 300 jobs. I think the UK is leading the market. So there is another technology on the market which is called Flettner rotors. That's being developed in Holland. It's being developed in Finland, but using the same team at University of Southampton. Wing sails are producing at least twice as many fuel and greenhouse gas savings. So we think we've got a superior technology. We think we've got capability in the UK, and we could really lead the world in wind assist for shipping. We are a sailing nation, and we are really good at it. So I think we can capitalise on that opportunity and create hundreds of jobs around the country.
Okay, we must leave it there, but it's been really good to talk to both of you today and have a little interruption from your cat as well, Di. Thank you, Di.
I've told her not to.
It's good to talk to you both. Thank you very much indeed for the insight today and joining us at Marine Tech Expo 2021. Some amazing stuff we heard about there and the UK's position in developing some of that technology. A short break coming up now, but when we come back, we'll look at how we monitor some of the technologies that we've been talking about, how we monitor their impact on the ocean, and we'll look at plans for Sail GP, which is coming to Plymouth. That's coming up after this break.